Now, for every state, you get an irrigation guide. Here's the state of Washington irrigation guide. And it's a 2-volume water encyclopedia, effectively, for the state. And in the first part, explains water irrigation techniques. And then the second half of the second volume is all the different soils and then all of the different weather, or excuse me, not weather, but consumptive use information for different sites throughout the state of Washington. So I'm just going to pull a soil out of here that looks interesting. I know we have a real divergent soil here in this valley, so I'm going to pull it out. Now on this page I have a soil called Yakima silt loam. Now there's a good one. Yakima silt loam is the typical soil we have over in the Walla Walla River Valley, going down through Milton Free Water and then out west of College Place and on down to the Touchy. Well, here's its profile. This is really an unusual one. The first foot, now it's a silt loam, so silt loam has a pretty good water holding capacity. It holds a bunch of water. The first foot holds 1/1700ths of an inch per inch. Now, this is available water holding capacity. Available water holding capacity. The second foot holds 1400ths of an inch per inch. Now what's that telling us about the soil? We're getting a profile change within that soil. In the second foot, we're getting something looking a little different. Okay, let's see what happens to the third foot. Third foot drops to 0.09 inches per inch. Again, more radical change yet is occurring. Now, what happens to the fourth and fifth foot? And we normally only value a soil to the 5 feet because we consider 5 feet probably the maximum growing root zone of most crops. And it dropped clear down to 0.03.
But is that totally due to a change in the content of the soil, or is that
Sure.
also due to a lot of times the water's being most of the water's being held by the first 3 feet?
Question is it a soil change or is it just where the water would stay in the profile? No, this is totally due to soil. They're looking at a soil and how much water it would hold individually at each different level. What does this tell us this soil is? We're out here in the riverbed, aren't we? It's either gravel or cobbles. It's rock. And there's nothing to hold the water. It just drains right through. You pour water on that soil as fast as you want, it's just going to pour right through. Because down there in the fourth and fifth foot, you're truly into the old riverbed. So there's virtually no water holding capacity at all. And you go out in the tree district in Milton Free Water and you look when they pull out an orchard, and they will pull out those trees and they only root that deep. Because there's nothing for the roots to go to. In the third, fourth, and fifth foot, it's just rock. No nutrients there, no water there, so they go laterally. So they got a great big dish for a root ball. Real big diameter, real thin. Not typical of what you would expect a tree rooting pattern to look like. But that's what ends up happening in a soil that is extremely divergent, where we have really good silt layer. We're starting to get some gravel mixed into it. We're starting to get a lot of gravel and rock mixed into it. We're into solid rock, the fourth and fifth foot. So that shows you a couple of things about soils, and that's how you need to be thinking when you're working out in the industry, is how is a plant going to behave in a given soil profile? And boy, does this tell the story on virtually any profile. The thing you want to know is what is the available water holding capacity. That's going to be the real clue to what you're going to be able to do as far as irrigation is concerned.